If you have either an inverter or non-inverter unit, but you haven't followed proper safety precautions, then you're at risk. Look, I've got a PCB here from a Sharp company unit. When excessive electricity flows into it, this 450 microfarad 400-volt capacitor has blown up. From the position, it's clear that the capacitor has swollen. Look at this one. It's slightly lifted at the top, and look at this other one. It's completely loose and freely rotating. So, if such a blast happens, it's your own fault. Now, you might ask, how is this my mistake? The voltage surged. Well, if you didn't follow the safety procedures, then yes, it's your mistake. If you don't install proper safety measures, like a voltage protector, an amperage or current protector, and if you haven't used a breaker for any kind of fluctuation or ensured proper earthing, then this is your own fault. Because companies make these products very well, especially Sharp, which is a top-class company. Now let's move on to the repair. First of all, we can see physically that these capacitors are damaged, but the damage at this point doesn't matter much. This is because these capacitors are connected to the entire system. Now, if we remove the heatsink, let me just quickly detach it. Alright, I've separated it from the heatsink. In this particular model, IGBT isn't used. Now, physically, we can see that these capacitors are bad, so let's remove them. But there's only one proper way to remove them. Look, both of these burst capacitors are completely ruined from the inside, and you can see they're moving when touched. This kind of situation arises when you haven't followed safety procedures. Next, we'll test the other two components. For testing, we'll use a multimeter, and it's set either to diode mode or continuity mode for testing. Here, we have a bridge rectifier, and we'll check if it's working or not. By placing the probes on the points, we can see here that it's showing 0. Let's check another spot. Here it seems fine. The main input power is perfectly fine, but the DC point is currently showing a short circuit. Let's change the polarity of the probes and check again, but it's still showing 0. Now, it's possible that the IPM could also be short-circuited. So, let me check the IPM by placing the negative probe on the negative terminal and the positive on the positive terminal. And yes, it's showing a short circuit. The next point, which is the W terminal, is fine. Similarly, the V terminal is also fine, and the U terminal at the end is also okay. Positive and negative terminals are short-circuited. Now, what exactly is shorted here? Is the bridge rectifier shorted or is the IPM shorted? Let's remove the bridge rectifier and check it again. Now that the bridge rectifier has cooled down, let's test it, and it's showing direct 0. This means our bridge rectifier is short-circuited. All points are shorted, so the bridge rectifier is gone. Next, let's check the IPM again. Placing the negative probe on the negative terminal and the positive on the positive terminal, it's also showing a short. The positive and negative are shorted, as it's displaying 0 here as well, meaning our IPM is finished. Let's check the bridge rectifier again. Now, when testing it again, it's showing perfectly fine. Look here and here. All points are showing okay. Let's switch the probes and test again. Yes, now it's showing completely fine. Earlier, it was showing faulty. Now, let's test the IPM again. Even though it wasn't hot at all, our bridge rectifier was the one that was hot. Let's place the positive probe on the positive terminal and the negative on the negative terminal again. The positive side is completely shorted, so there's no chance the IPM can be saved. A component that sometimes shows as okay and other times shows as directly shorted is faulty. If we install it again, the system will definitely produce some fault again. Now, should we continue working on this PCB or not? I'll tell you how. When the microcontroller gets shorted, the two capacitors, C98 and C46, also get shorted. If these two capacitors are short, you can assume the microcontroller is finished and there's no chance for repair. So let's check. First, let's test capacitor number 98. We'll place the probes in continuity mode. Look here, it's showing a voltage drop, which means this capacitor is fine. Similarly, let's check capacitor number 46. Here, it's showing a voltage drop of 0.731, which means this capacitor is also fine. If both of these are okay, then further work can be done on this board. If they were short-circuited, I would stop working on it immediately because the IPM is 100% faulty. The IPM has gone bad. Its part number is PSS Tero S92E6C. Now, let's confirm if this IPM is indeed faulty. We'll reverse the probes. It's showing 0.949, which is higher than expected, so its first point seems to be fine, and all other points are showing okay as well. Now I'm checking this PCB again, and we'll check it again in diode mode. We'll place the positive probe on the positive pin and the negative probe on the negative point, and both points showing 0.043. So there's still a short circuit present, and this IPM could be either okay or faulty. There's a possibility for both. For now, we'll remove it and focus on finding the fault, since the positive and negative are shorted. The capacitor connected to the positive and negative, capacitor C47, will be checked in continuity mode. Look, it's showing continuous continuity, but there shouldn't be any continuity here. So I'll remove this capacitor. I've now cut it off, and I'll check the continuity of this point and the other point. There's still continuity present, which means something else is shorted. We'll need to find what else is causing the short. Starting with the capacitor connected to this one, there's no continuity in that capacitor. There's also a diode here, so let's check it in diode mode. If the diode is shorted, it can also cause a short circuit. This diode, however, is perfectly fine. Next, let's check all the capacitors on the board in continuity mode. Capacitor C122 isn't shorted, and neither is capacitor C37. Now let's check capacitor C54. It's also fine. So, I've checked it again, and look, there's a small capacitor here, capacitor C48, that's beeping in continuity mode. Let's remove it first. I've taken it out, and now I'll check the system again in continuity mode. It's still showing continuity, which means the capacitor is fine. Next, I'll check the capacitor next to it, and it's also fine. After that, I'll check the diode here. This one is shorted. I'll remove this diode now. After removing it, let's check the system again in continuity mode, and let's recheck the capacitor. There's still a short circuit. It's possible that the fan IPM is short-circuited. There's also a Zener diode 3, that normally shows continuity here, as I've checked this in many systems before, but I'll remove it now since our whole system is showing a short circuit. First, I'll check this Zener diode in diode mode. Nothing shows up except on one side, so this diode is fine. Now, I'll check both points again, and the short is still present. Now the situation is somewhat clearer, but it's still not entirely obvious. However, I'll show you what I've found. Look at capacitor number C24. When I check its continuity, it's showing full continuity. In this kind of situation, the chances of a short circuit are higher. Let's remove capacitor number 24 as well. It's a 150 microfarad, 35 volts capacitor. As we continue troubleshooting, the issue is now pointing toward the microcontroller. I'll show you how the microcontroller might be shorted. There's still a chance that it might be okay. Look here at capacitor number 94. When I test it in continuity mode, it's showing a short circuit. The positive and negative points are connected to this point, and they are also linked to pin 1. You can see both pins are connected here. When there's a short circuit here, it means the microcontroller might also be shorted. As I mentioned earlier in the video, if there's a short circuit coming from this area, it could still cause problems, and most of the time, this is the issue. But this time, the problem is new. It's the first time I've seen such high voltage that has damaged the system all the way to the microcontroller. Now, let's see if our microcontroller is indeed shorted or not. This is our last chance. Once we remove the microcontroller, the short circuit is gone. And after checking the capacitors again, all the short circuits are gone. There's no short circuit left. Look at the meter. It's perfectly fine now, and the short circuit is completely cleared. This means our microcontroller was indeed shorted. Unfortunately, at this point, I have no other solution but to return the system to the customer, as there's nothing else we can do with the current situation. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.